Good morning and good afternoon, Dr. Juleli. Today we will present our risk management report for a restaurant management system that's called RMS. Okay, let's see. The RMS is a web-based system designed to improve restaurant operation by integrating menu management and order processing, payment handling and inventory tracking, and also we have employees, right? So we track employee scheduling into one platform. Okay, the systems are developed using agile methodology with React.js and Node.js, and also with a cloud database. The main goal is to increase operational efficiency, to improve the customer service and support better business decision makings. Okay, in this slide it shows the project team structure and the project basis of the restaurant management system. Okay, the team consists of a project manager who oversees the project, software developer who build the system, and uh, also there's a UI and UX designer who designs the user interface, right? Okay, and also we have the database administrator who manages the databases, and quality assurance team for checking the quality of the system later onwards or before sending to the customer. Okay, team responsible for asset testing is the project is carried out for 4 phases. Okay, they have a planning, development and testing and deployment, and ensuring the system is developed and delivered systematically. Okay, let's see how to estimate the project cost. We use 4 techniques. Okay, first, bottom up estimating. It's where we calculate the cost of each task and add them together. Okay, the second one is analogs of estimating. Okay, that's where we compare our project with a similar restaurant, others restaurants management system projects. It's like a third parametric estimating, which user factors such as salaries, hosting fees, and software costs. Okay, finally, PERT estimating, which consider the best case and worst case and most likely cost to produce the more accurate estimate. Okay, using these techniques, the total estimate project cost was calculated as 136,700 USD dollars. Okay, this slide shows the estimated cost of for each component of the restaurant management system project. Okay, the largest cost is the software developers at we paying for them a USD 54,000, followed by the project manager at 33,000, and other costs included with the UI UX designer, and also the database administrator and cloud hosting, software license tools, and quality test accuracy teams, and contingency reserve for unexpected expenses. Based on these estimates, the total project cost is 136,700,000 USD dollars.
My part of the presentation focus on cost budgeting and how we have strategically distributed our resources across the project timeline to ensure consistent funding and successful delivery. So our approach involves 3 main pillars, which is assigning cost to specific project phases, establishing a 5% contingency reserve for unforeseen scope changes, and allocating funds based on clear deliverables and milestones. So to manage this accurately, we have broken the project into 5 operational stage, which is the first one is planning and requirements. This involves stakeholder workshops and drafting the business requirement document. Second, core model development. This covers our database infrastructure and basic POS billing logic. And the third one is advanced integration. Here we focus on the kitchen display system, which is KDS, and automated inventory tracking. And fourth, testing and quality assurance. We will run comprehensive cycles including user acceptance testing UAT. And the last one is deployment. Finally, we migrate to the AWS cloud environment and onboard the restaurant staff. So turning to the cost budgeting timeline, our total project budget is $136,700. For month 1, which is for the planning, we have allocated $40,500 for initial architectural design and tool setups. So for month 2 to 5, which is for development, this is our most intensive phase, which budget at 90,500 to cover developer salaries, coding and system integration. In month 6, this is divided between testing in the first 2 weeks and deployment in the final week for the live transition. So finally, we have integrated 6,500 contingent. $6,500 for contingency reserve, and this 5% buffer is essential for managing risks and ensuring that any emergencies do not derail our project's financial health. And this concludes the budgeting and life cycle portion of our plan.
Next, I will explain the cost control process used in our restaurant management system project. Cost control is important because it helps monitor project expense and ensure that the project remains within the approved budget. It also helps manage any change that may affect the project financial performance. To control project costs, we use Earned Value Management or EVM. EVM is a project management technique that measures both cost and schedule performance. There are three main metrics used in EVM. Planned value, PV, which represent the budget cost of the work that was planned. Earned value, EV, which represent the budget cost of the work that has actually been complete. Actual cost, AC, which is the real amount of money spent on the project. Using this value, we calculate several performance indicators. First, cost variance, or CV, which is EV minus AC. If the result is negative, it means the project is spending more money than planned and is over budget. Second, schedule variance or SP, which is EV minus CV. A negative value indicates that the project is behind schedule. We also calculate cost performance index or CPI by dividing EV by AC. If CPI is less than 1, it shows cost inefficient and indicates the project is over budget. Similarly, schedule performance index or SPI. It is calculated by dividing EV by PV. If SPI is less than 1, it means the project is progressing slower than planned. To continuously monitor project performance, we use tools such as Microsoft Project, Jira, Primavera. These tools help us track project costs, resource usage, and milestones. In addition, we implement change control procedure where any change to the project scope or budget must be reviewed and approved before they are implemented. Overall, EVM and these monitoring tools help ensure that the project stays financially viable and progress according to plan.
So now, I will present the earned value management analysis for our restaurant management system, focusing on sections 5.1 and 5.2. At the start, the project was planned for 6 months with a total budget of $136,700. This gives us a monthly plan value of about $22,783. By month 4, the team had completed 66% of the work, slightly below the plan, which is 67%. The actual cost spent at this stage was $95,000, covering the development, design, testing, hosting, and license. From these figures, we calculate the earned value at $90,222. The cost variance is negative at $4,780, meaning the project is over budget. The schedule variance is at negative 910, showing a slight delay. The cost performance index is 0.95, which indicates cost inefficiency, while the schedule performance index is 0.99, showing that the schedule is nearly on track. Looking ahead, the estimate at completion is $143,894, which forecasts a budget overrun of about $7,194. In summary, the project is currently over budget and slightly behind schedule. If corrective actions are not taken, the project will exceed its budget by approximately $7,194. This highlights the importance of cost control and efficiency improvements moving forward.
Moving on to our strategies for cost and resources reduction. To ensure the project remain highly efficient, we focus on three key areas: optimizing software licenses, right-sizing our cloud resources, and streamline workflows. The first point is optimize software licenses. First, regarding software licenses, we plan to transition underutilized paid development tools over to free tiers or better alternatives. This eliminates unnecessary overhead during development phases without compromising the team's capabilities. The next point is right-sizing AWS resource. We are strategically managing our AWS environment. We will downgrade the cloud hosting environment to a lower tier development package during the remaining building phases. We only plan to scale up to a high tier package for the final production deployment. This prevents us from paying for premium computing power that we don't currently need. Lastly is streamline task workflows. Finally, we aim to streamline task workflows by automating manual pipeline tasks, such as basic unit testing integration. By automating these repetitive steps, we significantly reduce developer idle times and maximize activity coding hours, getting more value out of our development pipeline. Let us move forward to CPI comparison. Initially, as seen on the left, our earned value EV was 19,222, but our actual cost EC was higher at 95,000. This resulted in a CPI of 0.95, meaning we were slightly over budget and only operating at 95% cost efficiency. However, after implementing our cost reduction strategies, specifically by scaling back our own underutilized AWS package and streamlining software licenses, we successfully lowered our actual cost to 91,500 while keeping our earned value exactly the same. As a result, our CPI improved by 0.04, bringing up to 0.99, which is nearly a perfect one. This represents a massive jump from 99% budget efficiency. Ultimately, this quick adjustment successfully chopped 3,500 of our actual expenses without hurting our project progress or output. This proved that our resource reduction plan was both highly effective and necessary. Let us look at the conclusion and project financial summary based on our 4 months review. For our estimation strategy, we utilize a robust combination of bottom-up, analogous, parametric, and perf techniques to map out development, database administration, and licensing costs accurately. Looking at our current EVM status, we want to be completely transparent. We are currently slightly behind schedule with a schedule variance of negative 910. We are also over budget with a cost variance of negative 4,778, bringing our initial CPI to 0.95. However, this is where our cost reduction strategies actively change the trajectory of the project. By right-sizing our AWS cloud resource, consolid- consolidating software licenses, and optimizing team costs, we can successfully recover approximately 3,500. What improved because of this? It boosts our CPI back up to a highly efficient 0.99, and crucially, it drastically minimizes the forecast 7,194 budget overrun that we would have faced at completion if we didn't intervene. In short, while the initial 4 months review flagged budget and schedule pressures, our proactive recovery plan ensures that the project remains financially viable, highly efficient, and fully prepared for the final production deployment. Thank you.